Hello, folks, and welcome back to Taking the Tech Exam with WM7X. Today, we're going to be talking about transistors, and we've got a lot to cover. But before we start, let me ask you a question that might seem off topic, but it's really not. About how many grains of rice do you think are produced every year worldwide? It's got to be a huge number, right? Every single grain of rice in the whole world for a year. And it is. It's absolutely astronomical. It's 40 million billion grains of rice, which is just mind-blowing. But the electronics industry looked at that number and said, hold my beer. They produce about 10,000 times more transistors every year. 10,000 times. Now, these are all rough numbers, but they give you a good idea, I hope, of just how massively widespread these little parts are. And transistors are part of a family of components that are all made from materials called semiconductors. And the magic of a semiconductor is that you can make it conduct electricity or not conduct electricity or anything in between. It's incredibly flexible. And the simplest semiconductor we're going to talk about is called a diode. And it's like a one-way valve for electricity. And if you think about this in the water world with our picture here, if water comes in from the left side, it pushes open a flap and it can flow through. But if it comes from the right, it pushes the flap closed so nothing can get through. And even when the water is getting through, it takes some water pressure to get that flapper to open up. And as a result, the pressure coming out is going to be slightly less than the pressure going in. And depending on how the flapper is made and how the hinges are built, different valves will have different amounts of pressure drop. And diodes are like that too. They only let current flow in one direction. And they also lose some voltage along the way. And depending on how the diodes are built, they drop a different amount of voltage. But regardless of how they're made, the ends of a diode are called electrodes. We've got an input side that's called an anode, and an output side called the cathode. And this is just one of those things that you have to kind of learn. They aren't really obvious words. And by the way, the cathode end, the output, is usually marked with a stripe, as you can see in the picture here. All right, let's review with some exam questions. We know that diodes only let current flow in one direction, just like the flapper valve. We also know that some diodes drop more voltage than others, depending on how they're built. And hopefully we'll remember the names for the ends of the diode, anode and cathode, and that the cathode end is marked with a stripe. Okay, you may not have heard of diodes before, but I'm sure you've heard of LEDs. Pretty much every light we buy these days is an LED. And they're diodes. They're light-emitting diodes. That's what LED stands for. And so they still allow current to flow in only one direction because they're diodes. But these diodes light up when current passes through them. And remember how we said that there's a voltage drop across the diode because it takes some voltage to get them to open up? In a normal diode, that energy becomes heat. But in an LED, part of that forward current is turned into light. So that's where the light comes from. And the LED symbol looks like a normal diode, but it's got kind of a couple of rays of light coming out of it. And most of the time when you see something like a power indicator on your radio, that's an LED, unless it's a really old device. All right, let's review with some exam questions. First off, we know it's the forward current through an LED that makes it light up. And no surprise, LEDs are often used as indicators. Just like we said, the power indicator on your radio is typically an LED. All right, it's the moment you've all been waiting for, transistors. There's a lot of different kinds of transistors, and they come in different sorts of packages and sizes. But today we're going to focus on the two main types, which conveniently are also the ones that the exam cares about. There are also a bunch of different circuit symbols for transistors, but this is the only one that appears on the exam. Okay, but what does a transistor actually do? Well, first of all, it can act like an amplifier. So let's take a look at our water analogy. In this case, we've got a small pipe with a flapper in it, kind of like a diode. Then we've got a big pipe connected to it, and it's got a dam going across that gray piece. And you can see the flapper mechanism is actually connected to the dam. So if we send a little bit of water down that small pipe, that flapper's going to open up part way, and that's going to pull the dam out part way. And now water can start flowing through the big pipe, and it's a lot more water than we put into the little pipe to get that flapper to open. So in essence, we've amplified our small current in the little pipe into a much bigger current in the big pipe. And that ability to amplify is called gain. So a transistor can be an amplifier, but it can also be a switch. So let's start again with no water flowing in the small pipe or the big pipe. The flapper stays closed, so the big dam stays closed. And we call this the off state or the off position. But when we send enough water through the small pipe, it'll open the flapper up, and that will pull the dam all the way open. So now we get a full flow of water in the big pipe, and we say that it's on. So that's what we mean when we say a transistor can act as a switch. You don't flip a mechanical switch. You use a tiny input signal to switch a much bigger current. And you've got about 100 billion little transistor switches in your hand right now if you're watching this on your phone. They're microscopic transistors, in this case, inside your phone's processor and memory. All right, let's review that with a few of the exam questions. First off, we just learned that a transistor can act like a switch, and that we use the word gain to talk about amplifying a signal. And said another way, transistors can provide gain. They can act as amplifiers. All right, now that you know the basics, let's go a little bit deeper. If you look at the transistor symbol, you'll see that there's three main areas or regions. One is like the pipe coming in, another's like the pipe going out, and the one in the middle is the one that controls them, just like the small pipe. And all three of those regions are semiconductors. So transistors have three semiconductor regions in them. But there's different ways of making transistors work. This particular symbol is for what we call bipolar junction transistors. But that's kind of a mouthful, so we just call them BJTs for short. And each one of those connections in a BJT, they're also called electrodes, each one of those connections has a name. The input is the collector. It collects the incoming charges. The output is the emitter. It emits what comes through from the collector. And for historical reasons, the middle is called the base, and it controls the flow, just like the small pipe. There's another kind of transistor that you'll run into called a field effect transistor, or FET for short. Some people call them FETs. They're named that way because they use an electric field to control them. And they make up 99.9% of the transistors in your cell phone and more of the transistors in your radio. Now, you're not going to be asked about the symbol for an FET, but you will be asked about the names of the connections. And they're called gate, drain, and source. And they play similar roles to base, collector, and emitter in BJTs. It's just another one of those things that you have to kind of remember. But if you start using the parts regularly, they'll become second nature. All right, let's let all that sink in with another quick review. We know that transistors consist of 3 regions of semiconductor, and that the electrodes or the legs of BJTs are named emitter, base, and collector. And hopefully we remember that FET stands for field effect transistor, and that they have a gate, drain, and source. And you might want to review this section just to get those names really ingrained. All right, I know that was a ton of information, but I've got just one last thing that I want to mention, and that is that the vast, vast majority of transistors produced aren't individual components like these. They're actually microscopic parts that are inside of components that we call integrated circuits, or ICs for short. ICs also contain things like diodes, resistors, and capacitors, and all of them are tiny, actually microscopic. So if you see this question on your exam, you'll know that the answer is integrated circuit. All right, believe it or not, we barely scratched the surface on semiconductors and transistors, but knowing the principles and some of the terminology that you just learned will actually get you a long way. And fortunately, there are tons of good books and videos and classes out there if you want to learn more. And as always, if you have questions or comments, please leave them below. And if you want more tips on how to join the hobby or upgrade your license, click the subscribe button and ring the notification bell. We'll see you in the next video.